Okay, my friends, hey, just wanted to create this quick video. Wanted to help you review for the IRAT and TRAT for Chapter 4. Here are some suggestions, topics that may prove helpful in your preparation. Just wanted to outline quickly where these topics are at and give you a heads up on where to find them in the book. The first three topics are in Section 4.2, Theoretical and Effective Process Times. What is theoretical process time? Theoretical process time is described right here. Theoretical process time of an activity is the time of the main task of the activity without taking into account interruptions such as setups, rework, or failures. What is the effective process time? The effective process time of an activity is the sum of theoretical process time and supporting process tasks. Rework, setup, repair. Third question, what is an example of a non-value added task? That's actually a little bit higher here, talking about a supporting tasks. Here are some examples. Uh, Setting up a resource, maintenance and repair, doing rework to fix quality problems, etc. These are non-value added tasks. Some of the other topics here, let's go to the next two. These are in 4.3. So if we go to section 4.3 in the textbook, we can identify how to calculate a theoretical capacity per hour. So if I pull open my, oops, if I pull open my notes here, nope, not there. We'll go back. This section, section 4.3, talks about how to calculate the theoretical capacity per hour. We're also looking for to calculate a capacity improvement potential. Down at the bottom is the capacity improvement potential, both the percentage as well as the actual number. Up above here is calculating the theoretical capacity of a machine. If I highlight that, this quick example here, this is a spray painting machine. It performs a single activity of painting springs. And what they've done is they've had a number of parts that come through this machine, and they've split apart the different time. 2 minutes for the first part was the theoretical. There was no supporting task, so the effective was 2. If we come down to machine number 4, part number 4, M004, 2.1 minutes was the theoretical process time, but there was supporting tasks of 5 minutes. The paint was refilled. So the total effective time was 7.1 minutes. So to calculate the theoretical capacity of the machine, you add up all of the theoretical process times, which in this case was 40. There were 20 parts, so 40 divided by 20 is 2 minutes per spring. But to convert that to hours, we follow these steps. We do 2 divided by 60, which is 0.03 hours per spring, and we do 1 divided by that to get the number of springs per hour. That is the calculation there. And then again, the capacity improvement potential is down below in this section here. It's not showing up. I think there was a problem with the refresh. Let me show you what it really looks like in the textbook. I can refresh this page. Scroll down to the bottom. Here's the calculation there. So the CIP, the capacity improvement potential, is the theoretical capacity minus the effective capacity of that resource of the machine. And in this case, in this example, it's 10.74. We can also do the percentage capacity improvement. Next couple of questions. We have section 4.4. I'll go to the 4.4 section. Should idle time be included in the effective capacity calculation? Let's look at that. I love these 6 points, by the way, but I'm just going to highlight one here for the IRAT and the TRAT. It's not intended to be too buried here in the textbook. And I think this point is mentioned multiple times in the chapter, not just in this spot, but in this particular spot, it's saying um, an inefficient inventory control policy that does not order enough raw material, which results in the resource being idle. So if we don't have any parts to run the machine, it's going to result in idle time. This idle time should not affect the computation of effective capacity. It does affect the throughput. And this is, again, talked about a couple times throughout the chapter, I believe. And this is one example to answer that question. Let's go to section 4.6. What is the effective capacity of a pool of resources? And a pool consists of several resources performing the same activity independent of each other. So this means that every product that goes through this resource pool does not necessarily go through every resource in this pool, right? You can have two machines doing the same thing, and a single product would not need to go to both machines. And in this case, uh, each flow unit is processed by only one of the resources in the pool. Therefore, if we have two, in this case, two punch presses in the same resource pool, then we find the capacity of each station, of each punch press, and we add those together to get a total capacity for the pool of resources. So that's how you calculate an effective capacity of a pool of resources. Next one, 4.7.5. This is a great one. We will use this a lot in the course. How do you identify the effective capacity of a process? If we bring this up, oh, I lost my notes. The effective capacity of the process, right here, 4.7.5. The effective capacity of a process, in this case the drilling station, is the effective capacity of its bottleneck. And that's the answer. And to identify the effective capacity of a process, which usually includes multiple steps, is you find the resource or the step that is the bottleneck. And that is how you determine the effective capacity. And the other section that is represented here is talking about um, finding the effective capacity of a process. And in this case, what they've done is there's multiple products and multiple stages. And it turns out that after you find the effective capacity of the resources, that the effective capacity of the overall process is the resource that is the bottleneck. And you identify the bottleneck by looking at the effective capacity. So because Sam here has the lowest effective capacity of these three different resources, then this is the effective capacity of the overall process. And you can read some more about that to find out the details, but that's the answer to that one. Finally, how does the product mix affect capacity? Section 4.9, we're going to talk about product mix, and that's referring to the level of different products that go through the process. It's talking about product mix. In this particular case, let's see, where is it? Let's see, I'm pretty sure I highlighted it. Where's my highlight? Here it is. The principle is the impact of product mix on capacity. Changing product mix and process can change both the theoretical and effective capacities of the process. That's the principle. That's the idea. So you can read this section to figure out more about what does that mean and what is the impact of changing the product mix on capacity. And it turns out it changes both the theoretical and the effective capacities of the process. I think that's going to be helpful. Let me know what questions you have. Thanks.